Hello, everyone, and welcome to episode 17 of Nelson's Corner. We will be continuing with the card game engine. This will be part 8. Now, joining us tonight, of course, we have our host, Mr. Nelson Lackey. Nelson.
Hey.
And let's not forget the ever so wonderful student, Gavin.
Hello.
Hello. Also, we have both Zach.
Hello.
And myself, Jason. And in the far background, muted at the moment, we do have the awesome Twilight-loving Segfault. All right. So, continuing with where we left off last, let me hand this on over to Nelson.
Okay. So, the first thing that we're going to do is we're going to do some refactoring on our engine. Just a few things that I've kind of noticed and thought about and decided need to be changed.
Well, give us an overview before you dig down into it.
The first thing that I want to get rid of is all these loose GUIDs.
Okay.
And you notice that, like, for example, we have this deck and it takes a GUID ID. And if we look at the card game environment, there's a collection ID and a card ID both being passed as GUIDs. And the problem with GUIDs is they're not very semantic. I mean, I might as well just pass around like integer indexes, and it doesn't really feel right, especially once you start interacting with the engine in more ways. It starts to get really, really difficult to keep track of, what GUID goes where, what is this really an idea of, because a deck ID GUID makes no sense in the context of a collection ID, but it's the same type.
Right, for sure.
So
at what point did it start feeling odd to you?
When I started going over the card or the game object class, which we haven't really gotten to yet,
right?
Because that also deals a lot with GUIDs. And then I got in situations where I would need to refer back to a deck, and then I would have this card game object who had an ID of a GUID, and then the deck ID, which would also be a GUID, and then the method signatures would align up, and sometimes I would pass in the wrong GUID to some other thing. And it was just awful. So I kind of want to show people how to create a structure that acts exactly like a GUID, but forces semantics. And we'll also see how to reconcile that with the JSON serializer, because this will have different properties than GUIDs. Because GUIDs are immutable, but the JSON serializer knows how to deal with that. The GUID classes we're going to be writing, or the GUID wrappers that we're going to be writing, we're going to have to instruct the JSON serializer how to deal with that. So that'll be interesting.
Gavin, does this make sense to you?
Yeah, because otherwise, I mean, all you can tell from looking at it, away from its definition is that it's something unique.
Right.
Period.
That's literally all you can tell.
Right. Okay.
And then, in addition, our iCard definition is actually going to be moved into this folder, and then updated to namespace.
The abstract folder.
Yes. That was a different way that things could have gone, which they didn't. And then, in addition, all of these are going to be broken out into their own. All of this is going to be broken down to its own structure, because this is kind of, all of these properties do not have any meaning in the actual game themselves. All they are descriptiveness.
Correct.
Applied to a card definition for use in something that you would use to edit cards and stuff. None of these properties are going to be actually ever used in the card game, because we're going to go over a different system as to how the card runtime objects actually go about telling the world about what properties they have and how those change over time. Simple properties aren't going to apply in that case. So we're going to move that out, kind of get them out of the way. This is going to change to a card definition ID class, and that's really about it as far as the changes we're going to be making.
Okay.
Cool.
So yeah, to start on, let's go ahead and switch over the deck ID. So if we look at decks, we need to switch over that guy, and I believe there's references in the card game environment. We need to switch over... Or do I? No, I don't. I thought I had a method in there, but I guess I didn't. Oh, well, yeah. Yeah, exposing an IEnumerable of something is pretty much the equivalent of exposing an IEnumerable and, like, all of Link's methods, so I usually don't, add a get deck by ID unless there was any more behavior that needed to be done. But, so yeah. So we good start?
Yeah, absolutely.
Okay, so I'm just going to go ahead and create a structure called deck ID. And deck ID is going to take in a GUID as one of his constructors. And then he's also going to have a parameterless constructor that will just instantiate a deck by GUID.newGUID. And unfortunately, I can't do that because it's a structure. Why did I think I could do that? Oh yeah, because it's not a structure. Sweet. And this goes away. and that goes on top because it has fewer parameters. So that's that for now. However, in addition, I'm going to hit Control Insert and bring over the equality members.
Alt insert.
Yeah, Alt Insert. And Alt Insert E, you bring up the equality members. And what the equality members are is in order for a class to be treated properly within the context of a dictionary or any of the other collections, or really just in the .NET framework itself, it needs to have a bunch of different things implemented, especially the get hash code and the equals methods.
Mm-hmm.
And so ReSharper has this really convenient way to generate all this code for us, where all we have to do is say, what fields of this class do we want to use in determining equality between this class and another instance of this class? In this case, I'm going to check deck ID because that is the ID of this class, essentially. And I'm just going to hit Finish, and it's going to generate all this code. First of all, it started up here. It started implementing this interface. This interface is used, like I said, especially in like dictionaries for methods like index or lists, like methods like index of. Mm-hmm. And stuff like that. That uses this interface. All this interface does is force us to implement this equals method.
Okay.
But the important thing to know, and I'm going over this in great detail, especially for people who haven't, who don't have ReSharper. Mm-hmm. Equals is actually a method that's on every single object. It's inherited from the object class. And the reason why we need both of these, and you see this is an override. This is actually overriding the equals method from the base object class. This is implementing the iEquitable interface. And what's going on here, though, is we need both of these because if we cast, depending on casting and boxing, we can sometimes accidentally not call the right equals method. And we also want to be able to determine equality with objects that aren't the same type. And by returning false, essentially.
Yeah. So, now you said casting and what? Was that boxing?
Yes. Which isn't actually that isn't entirely applicable because this is now a class.
That's not a term I know.
That's a good topic for something in Nelson's Corner.
You could give them just a real quick overview about the concept of working with value types and
well, the idea is that in certain cases, you can cast an integer to an object. But what happens when you do that? What you're doing is you're taking a value type, which is a location on the stack, and you're now referencing it in the context of it as being a reference type by casting it to an object or an interface that is above it, or because interfaces are reference types as well. So you have this issue where this memory now needs to have things like a virtual function pointer table to be able to identify the proper methods to invoke on it when you invoke methods on it. Does that make sense?
Yeah. But
basically,
what effect does that have syntactically?
Not really any syntactically. Whenever you see yourself casting a value type into a reference type, and then especially once you see yourself passing that around to other methods that ask for reference types, that's when boxing occurs, and it occurs behind the scenes. It's a compiler thing. Okay. And basically what the compiler is it's turning that value object into a reference object, passing it around, and then when you turn it back into a value object, it unboxes it. And that's sort of an relatively expensive operation, so it's something you don't want to necessarily do a whole lot of.
Right.
So is that an adequate explanation, Jason?
Yeah, that's perfect.
Okay, so first we start with these equals methods, and they're virtually the same, except for this one has a check for the type. This one doesn't because the signature guarantees the type is the same. You see this reference equals, and you might be asking, why don't we just do this if this equals other? And I think hopefully ReSharper will catch this. No, it's not going to catch this. This will actually create a infinite loop. So if you're asking why we're using the reference equals method, which is a method available on all objects that does just what it says it is, these two references are equal, and then it'll return true. The reason we can't do this, the reason the reference equals method actually has to exist in the BCL is because in cases like this where we overload the equals operator. So if we did this to check to see if this reference was the same as this reference, this would actually execute this code.
Which executes that again.
That code. Yeah. So that's why they invented the reference equals method. This just compares if this pointer equals that pointer. Mm-hmm. So if it's null, then return false. If it's this, then return true. Otherwise, return the deck ID underscore, which remember is our field that we told ReSharper to consider the identifying unit of this class. Then we defer to its equals method. The less specific equals method, the equals method that would be called on if this was cast to an object, or was called against a type that isn't a deck ID, does the same thing. Reference equals. Then it checks the type, and if it's not the same type, it returns false. Otherwise, it does a casts, because now at this point it knows that this is a deck ID. It casts this object back into a deck ID and defers back to this method, which then does these two checks again, and then inevitably or eventually will check against the deck ID.
Right.
Would it affect? Would if they that additional if check, the type if check, was before the other two in that? Would
Yes.
that be problematic?
If it was before this one, no. If it was before this one, yes, because this makes sure that the object isn't null.
Yeah. Okay. But not the other one.
Right, because this is actually using the get type method, and the get type method is it's a method. If object is null, it'll throw an exception.
Okay.
Of course, if C# is a truly object-oriented language, null itself would be an object, which I think that's really cool. I like how Ruby does it, where nil is actually an object that you can extend and all that stuff.
You actually said I like how Ruby does it? Wow.
Oh, no, don't get me wrong.
I
Ruby's
know.
a language, but
It's the Ruby users.
It's the users.
Yeah,
the Rails crowd. Not
Rails.
necessarily-
Okay.
that's the Rails crowd, of course.
But yes, okay. So then we have the get hashcode method, and this is another method that's available on every single object that you might not have used before, but is incredibly important. That for identifying objects, you implement this. Basically, anytime you find that the class you're making is going to be used as a key to a dictionary, always implement this method. Because what happens is especially in the dictionary and the hash map classes, and it's perhaps used elsewhere, but it's primarily used in those two instances, they actually use this get hash code to optimize dictionary lookups. It determines what bucket it goes into, and we'll talk about the internals of dictionary sometime soon.
So, does hash code in this have a different meaning to, like, in sort of security verification?
Yes.
It's not the same, but it's not the same thing.
It's the same concept. It's a unique, and I'm finger quoting right now. It's a unique identifier for this object, but it cannot be relied on like an MD5 hash, particularly because it's just an integer. It's just 4 bytes. There are a lot of collisions. It's really supposed to be a very, very fast way to get a relatively unique identifier for an object, but hash collisions are acceptable. Another few important properties of this: you never want the result of this to change throughout this object's lifetime, ever, period. Ever. Because imagine if it's the get hash code return 5, and then you stuffed it in a dictionary, and then the hash code changed to 10. Now you'll never be able to find that again. Does that make sense?
Yeah.
Okay, so that's just a few different properties about the get hashcode method. It's very important to understand that, especially because we will be storing, I think at some point we're going to be storing this as a dictionary key.
But actually, I will revoke my former answer. There is one. No, would be closer.
Good
No,
man.
just in terms of why is get hash code necessary? Because we basically said that it's a unique way of identifying what it's
pseudo-unique.
Yeah, but it's a pseudo. So you've now got a pseudo-unique way of identifying something that is unique, the deck ID.
Well, see, the thing is that the BCL, the C# language, the .NET framework, has no way to know how to use this deck ID to determine a quality unless I tell it to, which is essentially what I'm doing right now. I'm deferring the get hash code to the deck ID .get hash code. Does that make sense?
Okay, yeah.
No, it doesn't. Come on,
Well,
Kevin.
okay. Well, my understanding of what you just said is basically that because deck ID, it doesn't know that it's a GUID. It might be an int. It might be whatever. using decid.get hashcode basically puts it in a guaranteeable form, so that or format would be a better. But it's like passing it into a particular into a hash code, which is. Jason, am I making any sense?
Keep going. You're doing
Keep
good.
going, yeah.
I'm trying to think of an analogy now. Basically,
See, this is. I want to throw this out real quick, Gavin, and to Nelson and to our viewers, because from time to time I'm going to be bringing this up. Nelson's going to be working with me on a very important C# fundamentals course that's coming up for Unity. And we're going to have Zach there as well. And Rebecca is going to be our star student, somebody who is completely new to the concept of programming. And we've already done some tests with Nelson. And Nelson being able to try to find a way to relate something that he knows to as simple of an explanation as possible is going to be very important. And sometimes, Gavin, students have a hard time finding the right words to put the question into. So keep trying.
right.
You could do it.
As far as C#'s aware, decid is essentially just a thing of some sort.
Do you
And therefore
mean this class decid, not this field?
No, the underscore.
Okay.
I was looking at the get hashcode where you're returning the hashcode of the decid.
Uh-huh.
It doesn't know what a decid is, therefore it has no way of knowing what constitutes two being equal. Therefore, the get hashcode basically translates it into a form that is consistent, so that it can compare. Yes.
Yeah,
Or predictable would be perhaps a better word.
If I had two decid class objects of this class and they both had the same inner GUID, they will both return the same get hashcode. They will be identical.
Yeah, but I mean, I'm asking about the reasoning for using it in the first place.
The get hash.
Why do you need it? Because decid is unique.
Well, hold on. Let's say we have two instances of this object, and we want a really quick way to compare them, kind of, but not with.
Oh, you're close. Keep going. You're real close, Nelson, to hitting it.
Well, no, it gets into kind of mathematics because the dictionary type uses this get hash code to index where in memory it puts your objects. So if I use this decid and I used it as a key, and then I use a different instance of this decid to look up that key, the dictionary ID is going to have to do a repeatable mathematical process to identify where in memory that value is.
So basically, it just makes it's a way of making it cheaper in some way.
Right. So now instead of the dictionary having to go, okay, instead of having to go through an entire list of object key pairs or key value pairs and compare each key with what you passed in, instead it can use this get hashcode integer to mathematically come up with a way to stick this in memory so that if you asked for a decid that was the exact same thing as what you've already stored, it'll
just got to go and grab it.
Yeah, it'll just go and grab it, and I'll find it instantly. And it'll make more sense once we talk about dictionaries, but that is the main instance in which I know get hashcode is used.
Mm-hmm.
I'm not... Are you aware of any other instances in the BCL?
No, that's kind of the big thing that I've always known.
Yeah, that's the big thing, because we are storing these decids in dictionaries, I think. But even if we aren't, it's an ID, and we should have that opportunity or have that ability.
No, I think that last description you gave Gavin was much better. Gavin, you feel good about this?
Yeah.
Okay, good.
Okay, so then we have these two guys, which are just operator overloads. I mean, are you familiar with operator overloads?
I'll answer for Gavin. No. Don't be shy, Gavin.
Basically, let's just go ahead and say a static blah.
I'm inhaling coffee.
Or static class blah and a static void. Basically, when we do this, what do you want to happen here, Gavin? Or, oh no, hold on. Let's do this. Because that was a bad example, actually. Now, this if statement, do you want this if statement to happen, to be considered true? Or do you want this if statement to be considered false?
True.
Okay, and the reason is because these two are equal values.
Mm-hmm.
The important thing, though, is that they're not equal references.
They're stored in two different places because they've got two different things.
In two different places of memory, exactly.
Very good.
So, by default, this equals operator will compare these by reference. It'll say, is this deck 1 in the same location of memory as this deck 2? Which is false. But because now we've implemented this equals operator and this not equals operator, by the way, you have to implement both of them if you implement one. And this will basically execute whenever this happens. These methods will execute instead of the default behavior. So now we have the opportunity. What?
But they're not overrides. I mean, they're not. They haven't got the override keyword.
Yes, because
I'm looking at them.
No, yes,
they don't.
No, yes, they don't. I know that was,
that was great.
That's because the equals or in C#, and I'm not going to say that there's no language that doesn't do this. I don't think there is a language that does this, but the object class, the class that everything inherits from, doesn't have a default implementation for this inside of itself. Does that make sense? Basically, this behavior of comparing references is something that the C# or is something that the CLR does behind the scenes.
Right.
This syntax, this operator overload syntax, is a way to tell it to do something different. But the important it just gets kind of messy, especially when you start talking about polymorphism and turning the deck ID into an object and then using the equals sign on it because this doesn't get injected into the virtual table, function pointer table as far as I'm aware. But basically, it's just a way to intercept these instances and make behavior that you think should happen. Funny story, slight aside, reason I hate Java, or one of the reasons I hate Java, is that the default string class, I'm not sure if you can overload the equals or the equality operator in Java or not. But the default string class does not re-implement it. And it is a class, it is a reference type, meaning every single time you say string 1 equals string 2, if those aren't the exact same instances of that string object, it'll return false. I was banging my head against my keyboard for hours trying to figure out it's maybe like one of these strings had like a UTF character that I just couldn't see right or something. It was the most miserable experience ever before I found that out. So yeah. So does equality operator overloading make sense?
Yeah. Is there a general rule for when you would essentially override something without using override?
Yes. The rule is that if it's a method that is marked virtual or abstract on any of the parent classes, then you use override. If it's an operator overload, you use static bool or static type operator. Is this
okay?
And that's also because you notice this is a static method. This is taking in two deck instances, and the reason this is also a static method instead of an instance method is because either one of these can be null. Does that make sense?
Yep.
Okay. So cool. That's our deck ID.
What?
No, I didn't realize there was so much to talk about with that. I always took that code for granted.
Gotta love ReSharper.
Yeah. It's like, yeah, okay. But
yeah, really, because it took how long to put in?
Well, let's talk about collection ID. Collection ID is going to be pretty straightforward. Oh, I did it again. Did you see what I did wrong, Gavin?
No, because you flashed it by in microseconds.
No, this code is wrong. You should always have the fewer parameters on the top. I don't know if that's a rule, but okay.
I tend to do them in order of line length. It just looks prettier. But anyway, carry on.
So this is the exact same code, but it's now
Yeah. That makes perfect sense.
Now we're going to do the card definition ID, which will be interesting because card definition ID is going to have two things. It's going to have a collection ID. Then it's also going to have a GUID for the actual card ID.
Mm-hmm.
And you'll notice something interesting about when I do this. I'm going to select both of these. I'm going to hit Finish. The interesting thing is this is all what you'd expect. Basically, instead of just comparing one, now it's comparing two things.
Yeah.
So it's comparing the collection ID and the card ID. Same with, that's just the only equals method that does anything, actually. But the get hash code is interesting.
Unchecked.
Yes. I don't think we've talked about unchecked before.
We have not.
The unchecked block, basically what happens when you have integer overflow, you get an exception.
Mm-hmm.
And we don't want that here because we're doing a bunch of crazy math. We don't care about overflows because essentially this is just an algorithm that will spit out a number.
Yeah.
So we mark it with unchecked to make sure that that doesn't throw an exception when bad stuff happens. Does that make sense?
So what happens instead when bad stuff happens?
Oh, just overflows like C++ or whatever.
Okay.
Okay, so yeah, that's that.
Okay.
Two other things, though. Actually, I forgot about this. You'll notice that we don't expose this GUID anywhere.
Mm-hmm.
It's not public, and I did that on purpose because I don't want you to think about deck IDs as in terms of GUIDs or what they contain internally. I want you to think of a deck ID as an atom or an atomic class. That's like the smallest unit that you actually use to increase the semantic value once we start doing code stuff. But sometimes you might want to print this out and actually see the GUID. So could you possibly guess what we're about to do?
Singleton?
No.
Do I not mean that?
No, you didn't mean that. You were just kidding.
Yeah. We're going to bring in a toString override, not overload.
And why are we not doing a singleton, Gavin?
Is it completely the wrong word?
Yeah.
Yeah. I didn't mean that.
I know you didn't because you didn't want the concept of locking us down to only having one deck ID ever.
Yeah, no, that wouldn't be ideal.
That would be less than ideal.
I was trying to be neat, you see, and use
just some fancy word that you didn't really know what it means. That's okay. That's cool.
Well, the thing is, I'd have looked. It was a 50-50, and not only would I have looked good if I'd got it right, but it would have confirmed it.
ToString is another one of those methods that originates all the way back up at object that every reference type has, and so we can just override it and control what we want to use when we do a ToString. Good try, Gavin. Good try.
So basically all we're doing is deferring to the GUID's toString. Does that make sense?
Yeah.
So whenever this is printed out to a console, this is what's going to happen. This is what's going to happen instead. The collection ID, we're going to do the same thing. If anybody still cares about all the awesome resharper stuff you can do, the quickest way to do this is Alt insert O downspace enter.
And the slow way?
You type it all out.
Like override void toString.
Ta-da.
I'm surprised you can remember how to do that.
Yeah, I was too, actually. I was thinking in my head, like, is override on the right side of the signature?
Oh, God. It's horrible.
Well, no, because I don't look at that, because look at this. You know, it shows you over here. I just got so used to looking at that symbol, and no, I don't want to look at that code. No, I don't want to look at that code. Okay, so that's that toString. This toString will be a bit different because there's two things that we want to look at. So I'm just going to say
toString.
Yeah, well, I'm just going to say collection that ID that. And remember, this is just for debugging insanity reasons. This isn't never rely on toString for anything because toString is always subject to change. You shouldn't use it for serialization whatsoever, just for debugging and output reasons. Okay, so is that all that good?
Yep.
Sweet. So let's go ahead and do our iCard definition next. So I'm going to yank all you guys out. And unfortunately, there's no Control-Shift-R make into structure button. There should be. But first I'm going to say this is now going to be a card definition ID. And then we're going to go down to value objects and create a card details class. And so you notice I just added a class to value objects card details. If you're wondering how I did that too, this is something that I was like, I really wish I knew how to do this. So I looked it up in the keyboard shortcuts, and it was so difficult for my fingers to get around it. But now that they can,
to get over to the Solution Explorer to automatically, yep.
Yeah, it's Control-Shift-L.
Right.
Or Control-Alt-L, sorry.
Oh, is it all?
Ah.
And then it's Escape to get back into the editor. So if you want to make a new class, Control-Alt-L, and then start typing in the namespace you want, like value objects, then Alt-Insert-C, and you're there. It's really beautiful.
Brilliant.
Anyways.
Yeah, having to move the mouse is actually, you're right, it is really annoying when you're coding.
Do like Nelson, man. Just throw your mouse away and replace your keyboard with one that has nothing on it but clear buttons.
And then you're
there.
truly...
Then you will be forced to work with keyboard only.
Well, haven't you noticed how much better I've gotten over the last few months?
You've gotten very good with it. Yes, I agree.
Almost as good as if you had the letter names written on. But I digress.
Very nice.
Okay, so we're going to be making a public string name set public string description, blah, 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 blah. This is all fairly irrelevant. We can deal with all this stuff later. No, I didn't want that. I wanted that. Okay, so that's just, we're going to fill this out. Basically, all this exists for, the card details, all it exists for is just for metadata that we might want to use to show a UI once in a while. None of this information is going to be used in the game whatsoever. It'll be used for, like, when we build the editor to actually build cards, that's where the details are going to be actually used. But I just wanted to marginalize them because they're not, these aren't going to be pulled over to the actual runtime. Okay, so good with that? Then let's go into the card collection, change this to card collection ID. Oh, did I call him collection ID? Yeah, I did. I'm actually renaming collection ID. Oh, I feel bad when I do this. Okay, so we're going to collection ID, and we're renaming this Control-RR to card collection ID. And that's all good. Okay, sweet. So now the card collection ID, then we go into the deck, and we put in a deck ID. And then we have already did the card deck definition. And then the deck factory, we now changed the set ID to deck ID. So basically we're just going along, and we're just changing all of the IDs from GUIDs over to the new types we just made. Now this is an interesting case where, I mean, it makes it a lot nicer because we have these two unrelated parameters to this method that are actually conceptually the same thing.
Yeah.
So now we can just replace this just with a card definition ID, called a card ID, and then that'll just clean up that signature quite a bit. And then we need the card collection factory. His set ID now takes a card collection ID, bring in that namespace, and he doesn't have anything else he needs. And then iCard game environment, this changes back to card definition ID, which just makes everything a lot cleaner. So I'm going to close all these, and then so everybody's good with the interfaces I just changed?
Mm-hmm. You, Gavin? Mm-hmm. You sure?
Yep.
Okay, good.
Yeah, definitely.
Okay, I'm going to close those. I'm going to make sure that there's nothing in here that I need to change. No. Make sure I don't think there's anything. Oh, I am going to have to change these two files, but I'll do those last. Value objects, we don't have to change anything in value objects, so now we can move on to our concrete classes. Card collection is just going to have a card collection, not surprisingly, a card collection ID. Now that's taking in the constructor. The card collection factory is now having a card collection ID, and that's all good. our card game environment. We'll do that after the deck and the deck
Remember,
factory.
slow down just a little, Nelson.
Okay, so now we're in our deck CS file, and we're going to be changing him over to deck ID. Yeah, it is really hard because this is really like autonomous kind of grunt work right now.
I know, but 10 frames a second, lag, etc.
Yeah, I know. So, yes, so there's our deck ID on that, and then we go to the deck factory, and we go and change his ID to the deck ID, set ID to deck ID. This guy gets changed over to the card definition ID, our add card method.
These guys.
This now changes into that, and then we're good.
Okay.
So now we can go into our card game environment and do all his stuff. This basically just changes to card definition ID instead of those two other ones, our get card definition method. Where are you? There we go. Now this is actually, I completely forgot about this. I did actually expose, or I should have exposed, sorry, this is a mistake, this card collection ID. Remember, the reason
The card definition ID one.
Yeah, inside card definition, I'm exposing card collection ID. The reason I'm doing that is because I can. The reason I didn't with the GUIDs is because I couldn't. If that makes sense.
Seems reasonable.
Well, remember how I said deck ID and card collection ID are both atomic? They're both, atomized. Card definition ID isn't. It actually is composite of another thing. So that's why we're going to expose this. Just conceptually makes more sense. And we're going to do that in a little roundabout way just because it's referenced all around here. So if you want to, if you don't have ReSharper, go ahead and change all these card collection IDs to the property version of a card collection ID. But if you have ReSharper, Control-Shift-R, encapsulate field, enter, and then go over to the thing you just created, Control-Shift or Control-Enter to automatic property, and then bring that up there.
Is there no shortcut? Is there no setting that can be changed to get properties up where they should be? Because it is really annoying.
You should be able to go in your ReSharper settings and change where it puts things by default, but sometimes it doesn't do it. Some refactorings decide to ignore the rules of good code for whatever reason.
Of Nelson code.
Yeah. Well, I mean, that is synonymous, correct?
Yeah, just move on. Just move on. I was waiting for that, so
Yeah, just you could feel it coming.
yeah. It's like hearing the train come down the track.
Yeah.
And I'm also going to rename this to collection ID because I think that flows better in that case. Okay, so now we go back to our card game environment. So now we can do card ID.collection ID without violating any terrible design principles, and then we're good.
Why have we still got red?
Because I'm blind.
Yeah.
That makes sense.
Okay, so are we good on this method?
Yep.
So now we go into, so I'm going to go ahead and close all these again. I'm going to make sure console is working. It should be working just fine. No, it doesn't. We have to do definition.details.name because remember we moved those properties into the value object. So now we need to do these guys. And the unfortunate thing is this isn't going to be as easy as you might think it would be. And
How are we doing for time?
We're okay. Let's go ahead and finish with this one video. Let's go ahead and get all of this refactoring all taken care of.
Because in order to do this, we're actually going to have to instruct the JSON converter. Remember, I pulled in the NewtonianSoft.json serializer, which is the most liked on NuGet, so it must be pretty good. I haven't had any problems with it. It's used quite a bit in a lot of open source projects. That's why I chose it instead of using Microsoft's serializer, which kind of sucks. We need to actually instruct it how to deal with deck IDs, because deck IDs do not have any public properties. There's nothing for it to latch onto. It can't well, I guess it could magically with reflection go in and view all the private properties, but that's actually not by convention how this JSON converter works. It works on public properties. This has no public properties, therefore this has no way of being serialized or deserialized. Does that make sense?
Yeah. Is there a reason why you can't do, for instance? Oh, you've gone off the screen.
Oh, sorry.
The like turn the public deck ID into make that a getter. Or setter.
Because I don't want the concepts of GUIDs anywhere, really. I don't want people to even think about GUIDs, and I know they have to because of the constructor. But if I were to ever change the implementation, or if I wanted to do something strange, or maybe add another layer of identification, I don't want people to cheat and start messing with deck IDs in terms of GUIDs. It's a kind of a philosophy of how I want people to use this design, sort of thing.
Okay.
Does that make? I mean, is that an acceptable reason?
Yeah. I mean, I was looking at it, and because it almost looked like a property, I thought, well, actually, why can't it be a property?
Yeah, it's yeah. You have to keep the code pure and perfect. But so our deck loading extensions, basically, if you remember, this guy pulls in this guy. And it matches up these JavaScript or JSON structures with these classes. So we need to change this to a card definition ID.
This being
these two properties, the collection ID and the card ID. We're now changing that over to be the composite of them. No. There we go. Nope. There's not an I in front of it. It's on the interface. There we go. And let's call that card ID. Get set. And then this is now a deck ID. And so, yeah. So now we need to reconcile this code. First of all, our factory add card just needs a card definition ID. So we can actually just change this to card.card ID to make that happy. And now it'll compile. But what will actually happen is these properties will be filled in with blank data. They'll actually use the default constructor. They won't use the constructor that we actually want them to.
right.
So we're going to go ahead and create some helper methods or some helper classes that we can inject into the JSON converter and make it work better with stuff.
Okay.
So I'm going to create a namespace called base in here. That's kind of the name I use for random infrastructure code stuff, things that I don't ever want to look at again. Kind of like the helpers, like this method, like JSON helper. And all this guy is going to do is he's going to go ahead and be essentially a factory for our JSON deserializer. Or not even a factory, he's going to be a facade over it because we want to be able to inject in all of these additional things we're doing to the JSON serializer in a centralized location. So we're going to say private static read only JSON serializer settings. I'm not going to be able to spell serialization. I've always had a problem with that word. We're going to keep his settings kind of cached. And then we're going to have a static method or static constructor that goes ahead and instantiates him in a particular way. And we're actually going to go ahead and not instantiate him just yet because we're going to fill up the settings by attaching other classes that we have yet to write, which I should have probably written first. So then we're going to have two methods on him. For right now, we're just actually going to have one method. We're going to have a deserialize method. Then I'm going to steal this, add a D to it. And then we're going to pass in TObject as a type parameter. And then we're going to say basically return JSON convert dot deserialize object of TObject with JSON. And then as a second object or second parameter, we're going to pass in the JSON serializer settings. And then this wants to be instantiated, of course, which we'll instantiate him in a second. So does that make sense?
Mm-hmm.
So now instead of in our deck loading extension, instead of doing JSON convert dot deserialize object, we'll just do JSON helper dot deserialize object. Or not. What's wrong with you? Did I misspell deserialize wrong? Oh yeah, deserializer. I'm stupid. Let's just pull in this and stuff it in that. There we go. So now we are running through this channel, and now we can do whatever we want with these settings. What we're going to be doing with the settings, though, is we're going to create these classes, like a collection ID converter, which is going to inherit from JSON converter. And JSON converter is a class provided by the Newtonsoft JSON library that allows
I don't know. I
us...
kind of like the Newtonian.
Yeah, I did.
That was pretty.
too, but
That's
I
pretty
was
wicked.
I was gonna let it go.
The Newtonian JSON class.
Yeah.
Anyways,
Yeah. So anyway, we have these methods, so we can now do stuff differently if we want to.
That was beautiful.
So basically what we're going to say, first thing we're going to say if object type is a type of card collection ID, then return true. So what this is saying is this converter will claim that if it's asked to either read or write an object of type card collection ID, this code will be executed instead of the default behavior, which, remember, the default behavior is to deal with external properties. Mm-hmm. So we're going to deal with the read JSON method here, or we're not going to deal with write JSON just yet. And the read JSON, all he's going to do is basically say return new card collection ID. I love how simple they made this API, by the way. New GUID, and then we're going to pass in reader.value.toString. Does that sort of make sense? Because it could be a little bit confusing to know what these objects are.
Gavin's not getting it.
I'm reading through it.
Oh, okay.
Well, let me pull up this again, and I'm going to put it down here. And then I'm going to hide this so I can take that and bring it over
So specific.
here. Why?
So much this and that.
I know.
Why? Seriously? Visual Studio?
Can you not move your mouth sideways?
No, I can't
Let
dock
go and-
right.
Let go and drag again.
There's no right docking point. Why would you? Why would you?
Oh.
Well, fine, we'll stick in a
Yeah.
little window up here. Okay, so you kind of have to see all of... Oh, you... You have to be... This is like a sick joke. Hold on, let me use my... Display Fusion to the rescue. Toggle, Windows always on. Top. There we go.
Don't worry. That means you're going to have your focus stuff stop responding in a few minutes. But keep going.
It's only Chrome. So I kind of wanted to bring all this stuff up at the same time because basically what happens when the JSON serializer, or in this case the JSON deserializer, hits this deck ID. Or why am I doing the collection ID first?
Win.
Well, let's just pretend this is a collection ID. Because the collection ID and the deck ID converter are identical. So I'm just going to... I know this is bad of me.
If you're not confused, Gavin, don't worry. Nelson
will be
will
in a
make
minute.
sure that you will be in just a moment.
I'm getting there.
Okay, good.
I'm getting confused.
I'm sure that makes him quite happy.
Just ignore me for one quick second. You're good at that. Come on.
Sorry, what?
Or Gavin.
Well timed. I appreciate that.
No, I was pointing that at Gavin. But
and he responded.
His response
and you
was
missed
beautifully.
It. That's great.
I timed it well, but I didn't aim very well.
No, you didn't.
Well, we
bit
picked
high.
up. We picked up on it. It was very well executed, I thought.
there we go. No. What are you... new GUID. Okay, so stop ignoring me right now. Kevin?
Can I stop ignoring you?
Yes, right now.
Ah,
Okay, so we have this read JSON method in here, and what's going to happen is the JSON deserializer is going to say, okay, they want a deck object. Okay?
Mm-hmm.
And at first it's going to hit this deck ID. It's going to say, okay, there is an object that they want of a type deck ID and has the name ID. So then it's going to jump over here and say, okay, here's this ID value that matches in the name to this deck ID property, but we don't necessarily know how to deal with this. So what we're going to do is we're going to execute this code right here our own custom code that's going to then construct the deck ID out of what needs to be done.
Yeah.
So right now, reader.value is literally sitting on this. Now, if this was a structure instead or an array, and you can handle these instances, it's a bit more complex to deal with that, but it's pretty straightforward API. So just know this isn't magic. This is because when the deserializer hits this property, matches it up with this value, then that's when it goes and asks your custom converters to go ahead and do the rest of the work. And at that point, reader.value is stuck on the proper position.
Yeah.
Okay, so now I can go ahead and move this up there and that close. So now we have these two. We have our collection ID converter and the deck ID converter. Then we're going to have a card definition ID converter. No, I do not want to create that. Did I misspell that? There we go. Gotta be kidding me. Resharper failed. So if our card definition ID equals the type that we're asking for, to read in this JSON, it's going to be a little bit more complicated. And what we're going to do is actually kind of cool. Basically, this card ID and this collection ID used to be different. Now they're the same. So what I'm going to do is I'm going to take this, move it like that, and put this into an object, and then make this have an ID property. So does this syntax make sense?
Yeah, it's just like we were talking about earlier today with vectors and doubles, and that it's sort of equivalent to that. Rather than having two doubles that are separate things, you just have a...
Right. And so our card ID now just becomes two different properties on a different object.
Mm-hmm. Yeah.
So now I'm just going to copy and paste that because I'm lazy. Copy that into that, copy that into that, copy that. No, copy that into that, delete that and that. Okay, so now we've just converted. Which leaves us with this, if you want to type that out. But basically all I did was I took these two card deck definitions and I made them similar in how they operate. Okay, so now we have this card ID object or this card ID property.
Can you just pop back to that? Because I thought you said the IDs were now the same.
No, the same format. With this new card, instead of before it was a card ID and a collection ID, now it's a card ID that is composed of...
Oh, I see. Sorry. I'm being dim.
Okay. So now this card ID will match up to this property right here, this card ID property, meaning once this JSON reader is sitting down here, it'll be pointing to this data structure. Now, here's the really awesome thing about how this person created this JSON reader. It's very, very modular and very awesome. Basically, what I can do is I can say values equals reader, and then just say, serializer, which is the, if you look at the fourth parameter, serializer dot deserialize, then pass in the dictionary of type string and string, and then inside of here, pass in the reader. So isn't that awesome?
Yes. I was just making sure I had which way was which in my head, serializing and deserializing. Deserializing is bringing it into C#, yes?
Yes.
Yeah, okay.
So basically, because this JavaScript this JavaScript library or this C# library has this special edge case for dictionaries of strings and strings, it'll actually properly fill out all of this stuff for us into this. So we're basically, this is just a way to kind of intercept that dictionary, turn it into a format that the deserializer understands, and then return it into a format that our program understands.
Yeah.
So we can go ahead and return new card definition. Or new card definition ID.
No.
Without that edge case for dictionaries...
Card definition ID. Okay, what is
Without that edge case for dictionaries, would you literally have to take in the dictionary and then go through each member and pass out.
I would have to
do actual string passing the old-fashioned way, and then drop it to the deserializer.
By using a combination of the reader and the serializer, I could just come up with a stream of strings if I wanted to. Basically, I could have access at this point to the entire abstract source tree of the JSON being deserialized. So I can do it manually if I wanted to. This is just a lot more convenient.
Yeah, I understand that. Clearly, it's one line.
So then card definition ID, and then we're going to put card collection ID as values. Collection ID, and then that's actually not right. It's new GUID values collection ID, and then new GUID values card ID, and it still doesn't like it. What don't you like about that? System GUID. Oh, right, because this is what happens when you get indentation wrong. Everything just blows up. There we go. So does this make sense?
Yes.
Sweet.
Yeah, it does.
So now at this point we can go back to our JSON helper, and we can fill out our JSON settings by telling it to use our converters that we just created. So I'm going to go ahead and use the property initialization syntax with converters, and then I'm going to use the array initialization syntax. This is a different. No, it's not a different namespace. It's just being dumb. And then I'm going to pass in a new card definition ID converter, a new collection ID converter, and a new deck ID converter.
Nice.
So now I'm tying up these classes I just created in this file to the settings, which are then passed into the deserializer when we actually go to deserialize something.
Lovely.
Sweet. So that's our deck pretty much done. If I go back to my our deck loading extensions, we're now using our card definition IDs and our deck IDs. We're not getting any warnings. The serializer knows how to deal with those. So now we can move on to our collection loading extensions. Unfortunately, this is going to be a lot easier, because all we need here is to change this to collection ID, card collection ID, and then we're done. Unless I'm missing
nice.
there. Because at this point, everything magically knows how to work. Okay, so now I'm going to hit F5, and we're going to get an exception. Or build error. Oh yeah, you. Huh.
Bye.
Yeah, we're going to have to redo. By the way, this is, if you didn't catch that, we're now in the...
This is the test stuff, the little fake cards we put together at the end of the last video.
We're just going to have to redo these really quickly. They have card definition IDs, and they also have deck details, or card details. I need to preserve this. ID is now a new one of these with a new card. I'll get that later. New GUID, pass it that. And then the card collection ID is going to be you.
That was from deck 1, Jason.
Yeah, I only have one collection ID generated right now, so it's always going to be the same. So you do that, you go there, then we instantiate our details, and our name is going to be Forest, and our description is going to be Boo. Our awesome creature is going to get the same treatment. I'm just going to copy and paste this over here. I'm going to copy paste all of this over here. Then I'm going to copy and paste this into that, this into that, and delete these two lines. So does that all make sense?
Yep.
All good? Okay, so now we're going to hit F5 and we're going to get an exception. Sweet, we got an exception. I didn't actually know, I just assumed.
It's a tradition or an old charter or something.
Yeah. It's having issues with error converting value to type card collection ID. Well, yes, that's why I created all of my stuff. Card collection ID. Let's look at our JSON helpers. and make sure that we don't double-click on it because Visual Studio decides to open up a new window if you do. Look at our collection ID converter. Can convert if the type is card collection ID. So let's make sure that this is even getting hit. Because it's not. That's bizarre. Oh, you know why it's not? Guess.
Because you're not using load collection from...
I forgot to do something in my collection loading. Give you a hint. It's on line 22.
Yes, actually use what you just created.
Yeah, I'm not using the JSON helpers. Dot to serialize JSON or JSON helper. Okay, so just maybe give us an exception. Oh, it does. Given key was not present in the dictionary. That's probably because of a mistake that I made. Let me make sure there's no interception. Okay, good. I probably didn't line up our in our JSON helpers. I probably did not line up these with what's in the actual deck.
Sorry,
yeah,
what
ID.
with what?
See, I'm using a card ID when I should be using an ID.
Oh, yes.
Yeah, so that didn't line up. So we're just going to refresh, and yay!
Very nice.
Woo!
Very cool.
So yeah, so now that we have that all stuff done.
Can you go back to the forest card a minute? The forest CS file.
Yeah.
Yeah, shouldn't it be showing woo for the forest?
No, that's the description, and I'm not actually printing that out.
Ah, sorry. Just checking because I expected to see it.
Yeah, well, we can go ahead and test our two-string methods too, actually. So I'm going to go ahead and say ID, name, description, and then it's going to be card.definition.id, card.definition.details.name, card.definition.details.description. Run it, and sweet. Our custom two-string method worked just fine.
Nice.
Nice.
So yeah, so that's all done. So we can, this is probably a good place to...
Yeah, absolutely. So
We've still got the rights to do.
Yeah, we'll deal with them later. We don't need them immediately.
Okay. Then with that, we'll go ahead and wrap this video up, and we will see you guys back in the next. Thanks a lot, everyone.